Namaskar. Myself Dr. Naveen, Professor, Department of Civil Engineering. Today I am going to discuss important topic, that is design of pile foundation. Firstly, we should understand the behavior of the pile foundation are the same as the other foundation. So, the objective of this pile design is to safe against the shear failure, then the settlement should be within permissible limit. There are 4 different methods to calculate the pile capacity. The first method is static method, then followed by the dynamic formula method, then in situ penetration test method. It means that we are conducting the pile capacity in the field, and then a pile load test. So, today I am going to discuss static pile load method concepts. Though see, this is the pile, this the total length, pile length will be denoted by capital L. See, this will be the QU, that will be ultimate pile load, and this is an homogeneous soil mass. See, this is a statical, vertically you are applying a load on the pile top. See, the objective is to determine the ultimate bearing capacity of the pile. So, when you are designing the pile, first thing we should understand the 2 concepts, one is skin friction, then is end bearing. Then let me understand what is skin friction concept, how it will work. See, this is the blue color which you are seeing is the arrow mark, that is the load, structural load coming on the pile. See, when that compression load is applied on the top of a pile. So, what will happen when the load is applied on the pile, it will tends to move vertically downwards relative to the surrounding soil. So, this is the surrounding soil, this is yellow color, and this will cause the shear stress. See, that will be developing between the soil and the surface of the shaft, means this is the concrete material and soil material. This applied load is distributed as a frictional load along a certain length. So, and that will be measured from the top of the pile. As the load increases, the frictional load distribution will extend more and more towards the tip of the pile until the certain load level. See, entire length of the pile involved is generated the frictional resistance. See, this is red color which you are seeing is frictional resistance. It will have some capacity to take this net. When this exceeds, then it will transfer to the pile tip, that is called end bearing. See, what is end bearing? When the load at the top of the pile exceeds from the skin friction, that is denoted by QS, the excess load begins to transfer to the soil at the base of the tip. See, which you are seeing, this is the base of the tip. This load is known as a point load, goes on increase till the soil at the base of the pile fails by punching shear. Generally, in deep foundation, pile will fail through punching shear only. So, the load bearing at this stage will be denoted by ultimate point load, that is denoted by capital QP. So, then the maximum load, how you will be calculating, that can be supported by the skin friction plus end bearing, that is we are denoting in the form of QU equals QP plus QS. So, if QP is means end bearing is greater than skin friction, then this pile is called as a point bearing pile, and similarly if skin friction QF is greater than QP, then it is called as a friction pile. Let me understand the mechanism by mathematical form. See, you are considering this pile, this is the total length L, this is the capital Q, this is the ultimate load. See, you are increasing, it is from ground level, that is why Z equals 0, you are going with respect to depth. So, what will happen? The partially load, the structural load will be taken care by the soil. See, that is why you are denoted by QS, or you can call this as a Q1, because here I am denoting by Q1. As you go further, see, this is the tip of the pile, see, this is below, this is called Q2, or this is the pile tip. So, when you combine this q1 plus 2 will be the ultimate. So, if you see this load transfer mechanism, what will happen? See, initially if it is measures are made obtained from the load carried by the pile shaft, it means that when you are transferring this structural load, this load will be taken care by the soil only. At the each depth you can see, at each depth you can able to calculate this. That is why this formula f of z equals delta qz by p into delta z. It means that p is nothing but perimeter of the cross section of the pile, z is nothing but depth. With respect to depth you can able to calculate. See, now you can see this, if the load at the ground surface is gradually increasing, this is the diagram. See, you can see as you increase this, the load is increasing, this frictional resistance of the pile shaft is fully mobilized. See, this is the picture, this is the fully mobilized. How you will be calculating? With help of this formula, f of z equals delta qz by p into delta z. Generally what is the rules? When the relative displacement between the soil and pile is 5 to 10 mm, and this is irrespective of the pile size and length. Similarly, when we come to load bearing pile, so this will not mobilize until the pile moved about 10 to 25% of the pile dia. See, this is the concept. See, you can see this, this is the vertical pile, you are transferring this structural load. As you increase this load, initially for small load this soil can able to take, there is no end bearing pile. As you increasing the load from q1, q2, q3 till qn, see, as you increase the load, initially this load will be taken by the soil, then the remaining will be transferred to the pile tip. So, then when you club it, you will get this term q equals qp plus qs. See, that is nothing but end bearing plus skin friction. See, that you can see this from the picture. Now, we have understood the end bearing and skin friction concept, but when you talking about the failure mechanism, especially with respect to defoundation, the ultimate load, that is failure surface in the soil at the pile. See, this is the pile tip of the pile. Generally it is in the defoundation, the mostly it will fail in the punching shear failure. See, this is the punching shear failure, you can see this. This is the, you have a two types of zone, zone 1 and zone 2. See, zone 1 is developed by the pile tip. See, when you are applying, because of that force this zone is developed. See, it means that it is a pushing downwards without producing any other visibility of slip sulfur. Similarly, this at this end, this is you can zone 2. See, that is will be the radial zone. This will be happening in the dense soil as well as silty clay concept. If you want to calculate pile capacity, this is the formula, ultimate pile load equals end bearing plus skin friction. That is why we are writing qp plus qs. If you observe this picture carefully, this is your concrete material. See, the load that is denoted by q, you are applying the structural load. See, it is going, as you increase the deeper depth, this load will be taken care by qs, that is skin friction. Then remaining will be taken by the rock or the pile tip. This will be the load taken by the soil and this will be taken by the rock. This is the qp. See, that is why we are mentioning qf equals net ultimate pile or load by pile which can be supported top at the failure, and this is the qb, this is the net load carried by the pile base, and qs, this will be load carried by the pile shaft. That is why we call as a skin friction. And the total resistance, how you will be calculating, this is the formula, total shaft resistance load by the pile equals qf equals f of b into ab. This is for the base pile tip and this is for the soil, this is fs into as. You are expanding that formula. Now, we will understand each component how it will be important in the pile design. First is point resistance, nothing but end bearing pile. So, what is that? You can see there will be no load taken by the soil, this will be directly taken by the rock, it means till the pile tip. See, this is the load that will be denoted by capital Q. See, this is the expansion, this is QP into AP. QP means ultimate bearing capacity of the soil into this is the area of the pile. Generally this will be a circular pile. When we are designing board cast density, it will be a circular pile. So, how these formulas are derived? These formulas are derived from the shallow foundation only by Terzaghis concept. So, this is the in case of sandy soil, and this is we are designing from the shallow foundation in sandy soil. What is the formula? For square footing, this will be QU equals Q into NQ plus 0.4 into gamma B and gamma. This is the bearing capacity equation. See, you are expanding capital Q, again you are expanding, this is a overburden, gamma into depth. See, this is the expansion. As you increasing depth, this also increases. This will be bearing capacity factor NQ and N gamma, and this is for the circular footing, same thing. See, for square footing it will be 0.4 gamma B and gamma, but in circular footing it will be 0.3 gamma B and gamma. See, Mayer of established effective vertical pressure, that is Q, at the pile tip increasing with the depth only until the certain until critical depth. It means that, see, gamma into D, that will be denoted by Q. It means that when you are applying a load, that load will be transferred only means that load will be taken to the certain depth. So, that will be, that depth is called critical depth. After that, what will happen? It will become uniform. You can see this curve. See, you are applying the load, it will be like this. At certain depth it will become constant, then it will be keep on increasing. So, that till that depth, this is denoted by critical depth, that is denoted by capital D suffix C. See, this is the concept of shallow foundation. See, when we are coming to the pile foundation, this is also similar type. Here also the critical depth depends on the angle of internal friction and the diameter of the pile. That is why if you see this chart D by B and this frictional angle, see, for 25 degree, 30 degree, 35 degree, 40 degree, 45. See, this will be the curve, it is there. You can, based on this you can able to see, and you can take this D by B ratio. The critical depth generally we will be taking 10 times the B, or for loose sand, and 20 times the B for dense sand. Here B is nothing but pile dia. See, we already understood the bearing capacity given by the Terzaghi. In my previous slide I showed you that, but here if you see this right side term that 0.4 gamma B and gamma has been cancelled. The reason, this is a circular pile. See, there the effect will be very small. So, that is why this term is not required, it is a negligible. So, when we are designing the piling, we will not consider this terminology here. Means this term is not required, only gamma, DC and NQ is sufficient. Similarly, for the circular foundation, see, that is why what is Q? Q is nothing but effective vertical pressure at the pile tip, and gamma is nothing but your unit weight of the soil in the zone of pile tip, and DC is nothing but critical depth. This NQ and N gamma are the bearing capacity factor. Again, this will be depends on the friction angle. See, if your friction angle is 20, then you will get NQ and gamma different values. If you are 25, then it will be again. That is why we have learned that in from the previous slide. Here B is nothing but D, that is pile diameter. See, that is why we are writing this formula for square foundation or a circular. This is gamma, this is the DC into NQ, and similarly you can see this is the chart. If you see this chart very carefully, you can understand on the y axis it is a bearing capacity factor, that is NQ. It will be starting from 0 and it will go till 1000, and here in x axis you can see that angle of shearing resistance, it means that friction angle. See, this how you will be getting, it will be getting through laboratory test. Each soil will have a different friction angle. So, you can able to see from after conducting the laboratory test, you will get the friction angle. For that friction angle, you will be able to take that NQ value for the respective depth. See, you can see from 5 degree, 10 degree, 15 degree, 20 degree, 25, 30, 35, 40, 45. See, you can see this NQ value is there, D by B also is there. See, this chart is from the Meyerhof bearing capacity chart. This is. So, what Meyerhof method will talk about this pile tip. So, here is saying the variation of NQ with soil friction angle means definitely, that is why we have learned this. You can see this NQ value, again it is depends on the friction angle, that is why he is saying that. And also the next condition, this QP means end bearing should not exceed the limiting value. It means that AP into Q1, see that is this formula, this is the end bearing formula, AP into Q into NQ. See, your should not exceed, that is why. What do you mean by Q? Q is nothing but effective vertical pressure at the pile tip. So, that is nothing but gamma into D. See, that is why it will be keep on increasing with each respective depth. You have a different density and different depth. See, as you go on, this will be keep on changing. And also here they are telling that the Q1 what you are calculating, they have the limiting stress, that is the formula 50 NQ into tan phi. They have a limited less than or equal to 11,000 kPa. We should be carefully for critical parameter. Next thing is N values. The N values, how it will be depending? See, assume that the soil above the pile tip is similar to the soil below the pile tip. We are making some assumptions. And also, if the pile penetrates the above hard or compacted stratum only slightly and soil above the pile tip is loose stratum, then, and it would be more appropriate to use the value of NQ for shallow foundation. See, this is the NQ values, how it is depending. See, you can see this picture. See, this is your pile, this is your vertical load, that is denoted by Q, this is your ground level. So, you have a two types of stratification. One is loose stratum, it may be a soft soil, and this is in a bearing set. In that case, see, if it is in a completely soft soil, this entire load will be taken by this layer in hard strata or stiff thing. So, that is why this concept will be applied. In that case, see dB, it means that depth of embedded in the bearing strata, you are socketing that much. See, that is the point bearing capacity, that is denoted by QP of the pile generally increases with the depth of embedded in the bearing strata. See, you have to do the socketing in this stratum. Next thing, how, see, this dB depth of embedded reaches the maximum value at an embedded ratio, that will be, it should be a D by B. See, this is the condition, this D by B CR, it means that critical ratio, that again depends on the soil frictional angle, and this will be determines the NQ. You can see this. See, it is all interlinked to the NQ. If it is this, again, because why it is coming? Because the soil friction angle is there. If it is there, then again NQ. See, from this method we have seen that graph also D by B. So, with that help you can able to take the NQ value. See, NQ value can be taken by based on the friction angle also, or by D by B critical ratio thing also. See, the thing here they are telling it should be limited to less or equal to 11,000 kPa. see capital D is nothing but depth of the penetration in the dense soil, then it will be less than equal to 10B. See they are giving, if it is Q1, then the limiting unit point resistance for the loose sand, then it will be 50 NQ tan phi, and this is, see this we have a two stratification, that is why loose and dense. So here the next, if it is there, then it will be limiting unit point resistance of the dense sand will be 50 NQ2 tan phi 2. The unit will be kilonewton per meter square. See capital D will be depth of the penetration in the dense soil. For a clay, see if it is a clay, then this will be the formula CNC plus QNQ. See generally C equals cohesion, the bearing capacity, NC is the bearing capacity factor for the D foundation. Generally what we will do, we will take 9 for the pile, but it may vary for some cases. So then the formula will be like QP equals 9 CNC into AP. See this is the analysis capacity of the clay. This is the bearing resistance will be CNC. See this is C is a cohesion below the base, that will be the undrained cohesion, and NC is a bearing capacity factor, generally taken 9. See this is the pile capacity in this sand, this is the by effective stress method, this is the formula. Now we will see the skin friction, that will be denoted by QS. So what is skin friction? Skin friction is nothing but the load taken completely by the soil. So how it will be analyzed? By Fs into AS. Fs is nothing but cumulative average unit friction between the sand and the pile surface, and A is nothing but effective surface area, it is nothing but perimeter into length. See this is the formula. Fs, how you will be calculating? K into sigma V into tan delta. K is nothing but coefficient of earth pressure, sigma V is nothing but effective vertical pressure at the depth under consideration, and delta is the coefficient of friction between the soil and pile material. Generally the critical depth will be 15 times the pile dia. See you can see this, the nature. See as you increasing the pile, what will happen in the pile installation? The driven pile in the sand, because of this vibration, the pile gets densifying the soil surrounding the pile, and the unit skin friction with the depth may more or less it become a linear to the depth. The magnitude of the critical depth may be 15 to 20 times the pile dia, that is why we used to take 15 times the D. So and similarly this is the critical depth, you can see the formula, it will be F equals K into sigma V into tan delta. K is nothing but effective earth coefficient, sigma dash V is nothing but effective vertical stress at the depth under consideration, and delta is nothing but this is the soil pile friction angle. See you can see this when we are talking about K, K is nothing but your Rankine passive earth pressure. So again for different types of pile you will have a board, it will be K naught equals 1 minus sin phi, low displacement, this is the formula 1.4 into 1 minus, and I displacement driven pile 1.8. See for if you see this, for different types of soil stratification, loose, medium and dense you have, and the density is also there. For different types of material like driven pile or board, you can take this K value as per this, and also this bearing capacity factor is also there. See quickly, this is driven piles in the clay. See this is the formula QS into Fs into As. See this is the chart, undrained cohesion will be in the x axis. See this is another method, here this will be calculated by QS into same, but this formula is taken by this by this reference. You can see this is the chart, lambda in the x axis and y axis will be the plane displacement. See before performing this method, you should be very careful to calculate C and C and dash, what all the points should be remember? Clay get remolded when pile is driven, remolding factor must be taken into account, remolded strength must always be less than the undisturbed strength, strength improves with time, rate of gain of the strength depends upon consolidation characteristics, rate of dissipation of excess pore water pressure. See, this is the pile capacity formula for the skin friction in the clay. Let us summary of the today's presentation. We have understood behavior of the pile design, and mainly today we have concentrated static method concept for the end bearing as well as skin friction concept for different types of soil, sandy soil as well as clay soil. In next session I will be going to discuss on dynamic formula and in situ penetration test concept and pile load test. So, other three methods we can able to calculate the pile capacity. So, thank you.